Moving on, we need now to take a 6 electron pair case, but 5 of the electron pairs are bonding, and one of them is non-bonding. And in this category, we take bromine pentafluoride as an example. So we begin always with calculating the number of valence electrons in bromine pentafluoride. So for bromine it is 7, and there are 5 fluorine atoms, and each of them contributes 7 valence electrons. Fluorine and bromine are located in the halogens group 7A. Therefore, each of them has 7 valence electrons. So the total number of valence electrons in this case would be 42. If you divide 42 by 2, we get 21 electron pairs. So there are therefore 42 valence electrons in bromine pentafluoride and 21 electron pairs. In order to draw a reasonable Lewis structure, we begin with drawing the central bromine atom. So that's the central bromine atom, which should be surrounded by 5 fluorine atoms. So that's 3, 4, 5. Next step would be to draw a bond between the central bromine atom and each of these fluorine atoms, like that. The following step, as you might expect, is to satisfy the octet rule on each of these surrounding fluorine atoms. Each of them so far is surrounded by 2, but that's not sufficient according to the octet rule. We need to make sure that each of them is surrounded by 8. So 2 plus additional 6 on each of them gives us 8 on each of them. So each of them has now satisfied the octet. Each of them is surrounded by 8 electrons according to the octet rule. If you calculate the total number of valence electrons used up so far in this Lewis structure, you will find it's 8 by 5, that's 40, but we had 42 before, so we have 2 to go. And these 2 should be drawn on the central bromine atom in the form of non-bonding electrons, or a non-bonding pair, or a lone pair, if you like. Now, the arrangement of electron pairs, since there are 5 bonding, 1 non-bonding, so the arrangement of electron pairs is still octahedral, but the molecular shape may not be octahedral, and that's because of the presence of a lone pair. Now, the molecular shape, that's the lone pair now, okay? That's like the central bromine atom, and these are the surrounding fluorine atoms. If you look at this shape, you would find out that's actually square pyramidal. So it's like a pyramid which takes the shape of a square. So the base is like a square, but it's pyramidal too. Okay, so the molecular shape is actually square pyramidal, square pyramidal in this 6 electron pair case, where 5 of them are bonding and 1 of them is non-bonding. To conclude, in the bromine pentafluoride 6 electronic case, 5 electron pairs are bonding, 1 of them is non-bonding. The orbital shape, or the arrangement of electron pairs, is octahedral, whereas the molecular shape is square pyramidal, and that's due to the presence of a lone pair on the central bromine atom.